SQL versus NoSQL. Which database you are going to use to your application? It is the very first question comes to your mind when you're going to start designing your application. And it is also a factor which will decide that how much rework you are going to do on your application when your data starts growing, when your customer starts growing. So in this video, I'm going to teach you the basics about the SQL and NoSQL, and from there you will be able to decide as a system design engineer that which kind of database you need for your application. So without any delay, let's see what we are going to learn in this part. So in this part, we are going to learn this SQL, the rigid table and data integrity. So first of all, we understand what is the SQL and what benefit it provide. Then we are going to understand this NoSQL and what benefit this NoSQL provide. Then we are going to see the real world application which using this SQL and also this NoSQL. By understanding the SQL and by understanding this NoSQL and then seeing the example, it will make us clear that which kind of database goes to which kind of application. And then we are going to coverage the hybrid DBs because right now these technologies are evolving itself. Even SQL is also evolving itself, and NoSQL is also evolving itself. So we need to see that what hybrid DBs are. Then in the last, we are going to see some questions of this system design to understand that whatever we have learned, actually we understood it. Okay, so first of all, we are going to understand this SQL database. What is this SQL database? So this SQL database is simply, it used fixed schema and data must perfectly match the schema to enter. Okay, so when you decide to use this SQL database, what it do whenever you create a data table, you are creating a contract with that DB engine that okay, I have created this table have these kind of columns, and these columns have these kind of type. As you can see here, this ID is serial, it is a primary key, then this email is of type varchar, and etc. Like there are multiple columns and those columns have their own type. So what will happen? Let's say if I try to insert age, which is not uh, defined in my table, and if I try to insert that particular data into my table, it will simply reject it. So what it provide? It provide me a security, a sense of security that whatever the data I need, that only particular that data is present inside my DB, and that DB is working completely on this structured way, the structured table, and that structured table have the structured column, and that column you can define that what type of data you are expecting. Sorry, what kind of data you are expecting there. Okay, then relational joins. Okay, I have two different tables, but they all are relevant to each other. It means I need some data of the user to create an order inside the order table. So what I do, I can join those table from the foreign key and primary key, and based on that, I can create a relation between these two tables. And also, it ensures that there is no data redundancy. It means each table will have the unique data, and there is no need to save the user address 50 times into 50 different tables. All you need is a one single table which is holding the addresses of the users, and that particular address can be referenced to the other table. So it saves us data. It provide us structure. Then ACID compliances. What I mean by the ACID compliances, that is all or nothing. What I mean by all or nothing, let's say you are doing some transaction between two tables or two DBs, then it's it might be possible that at some point, because of some connectivity issue or because of some irrelevant keys issue, your transaction got cancelled, and because it got cancelled, everything will be rolled back. So all or nothing means if the transaction is good, then every table will be updated. And if transaction is bad, then it means all the transactions will be rolled back for that particular point of transaction. Okay, so it is a one point of this ACID compliance. Then this isolation, concurrent transactions don't interfere. It means if two transactions are running, then they will not interfere with each other. Once saved, it will be saved there, even if your system got crashed. What I mean by system got crashed, so it will store data as on your hard disk, and as a property of this hard disk, you can restart it, and you will find the data same at the same place again. And also, there's one more thing. Okay, fine. This is the ACID compliances. Okay, let's go to the next slide. Connecting Python to SQL. Okay, so there's this very one good thing, this API model. So when it comes to fast API, we get this SQL model. But not only in FastAPI, even if we go to Django framework of this Python, there we can also create an ORM model. So in FastAPI, we can create an ORM model. In Django also, we can create an ORM model. And also in Java application and in other language application, we might define this ORM. I'm not aware of, but in Python, yes, we can. And why we should use this ORM model? Because we do not want to write these SQL queries every time, or we should not execute these SQL queries every time when we want to insert data, update data, or delete data. We should use these ORM model to define that table structure, and also it will provide us functionality to write a code in a way that we can define that which kind of column should have which kind of data. Okay, so this map to the database. So if you have defined your ORM model, you just need to run few Python commands, and it will create database automatically into your database. Sorry, it will create table automatically into your database, and you do not need to write any injection queries or insert queries inside that DB. So it is something which we all should follow. Let's move to the next slide. Okay, NoSQL. So we understood about this MySQL, that the SQL is good for structured data. The SQL is providing us the functionality like there is no redundancy of data across all the database, and it is also saving some data for us for the memory specification, and it is very robust in terms of transactions. When it comes to NoSQL, it provides us a very simple way of storing data. It is completely like JSON. So how it works, how this NoSQL works. So here you can see this user document. It is in JSON or BSON. BSON is the binary JSON. You can use the binary JSON also to insert data there. And is this JSON is something where we are not providing any kind of hard limitation that our database only accept if only these keys are available. So let's say if for some query my data got increased. Earlier I had this ID and name, but right now I had this inventory too. I had this level too. Let's come to the scenario of game. So in that game, there are multiple users. Each user will have their own character. Each user will have their own kind of inventory. They will have their own kind of appearance, their clothes. And if your game is running worldwide, like it might be possible that there are thousands of users which are doing something all the time, there will be lots of data which you need to insert at your database if you are using SQL. So how we are going to handle this kind of large data and unstructured data? Because it might be possible the user which is in experience state, that user will have lots of things as a as in user profile, and the particular data who is new to this game, that user will have fewer items. So how we are going to handle these kinds of things? Because if we are going to write a very structured data in a SQL way, then it means we are going to provide null to all the columns of that table, and that will still take the space. So how we are going to handle this? That thing we are going to handle with the NoSQL. When the data is very abrupt, you don't know like what kind of structure or what kind of data user is going to send, but that all data is essential for you. All data is essential for your application. There we use the NoSQL. NoSQL simply defines that whatever the data you are sending through to this DB, your application is capable of handling this kind of data. So there is no need to structure your data. All you need your keys and the values. that are present inside the JSON. And what is the horizontal scaling? So let's say scaling is very easy when it comes to NoSQL. And why I'm saying that? Because let's say you have your DB server, and that DB server you need to scale, and you are going to scale it horizontally. Then you are going to sharding technology to scale your DB server. And how it going to behave? That let's say user one is going to save the data inside the server one, and user two data will be saved on server two. So in this way, you just segregated the user numbers for one server and the user numbers for second server. So every time when that particular user is going to log in, that particular user will be redirected to the database server as server one, and whatever the information as a JSON provided there, that will be completely fetched without any join query, without any update query, or without any union. The complete data will be fetched as JSON, and it will be represented to user, and user will see that okay, these many things comes at just in a very fraction of seconds. So that is why this NoSQL is also good. And when the again, I'm saying when the data is abrupt, you don't know like how many fields can be there when it comes to your application, because it might be possible that in future you are going to introduce few more items, few more features, and that also will be the part of your application. So you are going to handle the everything from the code, and there you got the flexibility inside your database. Okay, so we understood what this uh, NoSQL is and where this NoSQL is used. Now comes to the real world application, this Stripe. Stripe is using this SQL, this PostgreSQL database. And why this Stripe is using this PostgreSQL database? Because it's a financial application. When it comes to the financial application, fields are limited. There is no abrupt data. And this field and this financial transactions should be monitored with the ACID compliance. That is why we are using the SQL database when it comes to Stripe or any financial application. Okay, Shopify. Shopify is also using the MySQL. E-commerce required strict inventory management. So everything comes from manage inventory, and this application need to be updated in a way so that any other transaction happen for that particular inventory, so that your application knows that okay, only this much quantity is present right now for me to sell. So in this way, this Shopify also using the SQL. And there's a one more scenario. Let's say in your inventory, you have this iPhone, and you have only one iPhone in your inventory, and there are two users who ordered this iPhone simultaneously. Then what will happen? So let's say if this transaction is going to happen in a way that once whatever the user's query occurred, because it might be possible that user one is just going to pay for that particular item, at the same time user two is also going to pay for that particular item. So at the time when this user one is going to pay for that particular item and the transaction is started, at that time that particular inventory will be logged, that particular row will be logged. And when this row will be logged, the user 2 will not be able to proceed with the transaction until the user's one transaction is failed or completed. So if it is completed, it means your inventory will become 0, and user 2 will be notified that hey, this item is out of stock. Okay, so we understood the scenario that what Shopify is using and what Stripe is using. Now comes to the Uber. This Uber is using NoSQL. And why this Uber is using NoSQL? Because this Uber cabs are moving from one place to another place. They are going to record multiple dimensions from the real world, or for the earth, from the earth. And it might be possible that user don't require to know that at which location currently right now your cab is. It might be possible that at sometimes the data which is getting transferred to this particular database got missed, and again it got connected, and after some time again it started to showing that okay, your route is this one. So there is uncertainty, and there is lots of data which is updating every seconds. So this Cassandra or Dynamo is using this, it is using NoSQL as a Cassandra or DynamoDB. Now, coming to the Discord, Discord is also using the NoSQL. Uses Cassandra. Billions of chat messages are sent a day, perfect for a wide column NoSQL store that cells at extremely fast write speed. So we just understand this why Discord is using the NoSQL, because when it comes to sending a message, so it might be possible that you are sending some kind of media. This media can be anything. It might be a video, it might be a audio, it might be a zip file, it might be a tar file, it can be anything. Or you are at the same time you are posting something, you are updating your status, you are sending messages to multiple people. So these kind of transactions cannot be handled through the SQL rigid queries, and that will also take time because billions of customers are using your application simultaneously and they are doing lots of stuff. So what you would do, in place of creating a structured database, what you do is you create just a NoSQL database, and inside that NoSQL database you just provide one column to that particular user, and whatever the activity that user do, that will be saved in a sequential order to that particular user. And when the user comes back and or you want to revert that particular data to that user, all you need to do is you just need to go to that column and fetch that data for that user. So in this way, this data transactions become too fast for that user with the NoSQL database. Again, when that data is too much and too uncertain. Fine. So we understood this application usage of the SQL and NoSQL database. Now let's come to the modern coverage. So currently we have these two kind of DBs. One is SQL and one is NoSQL. So this PostgreSQL is representing the SQL and this MongoDB is representing the NoSQL. But what is the modern coverage? So currently this PostgreSQL or this SQL is also getting to know that hey, these users are there are many users who are using this NoSQL and it is getting famous, so I need that feature. At the same time, this NoSQL DBs are also getting this hint that okay, there are multiple users who are using the structured data DB and relational DB, and I need that feature. So somehow this SQL is adopting the NoSQL thing of this unstructured data, and also this NoSQL is also adopting the things from this SQL, the structured data. So right now, these DBs are providing you the hybrid way, because in PostgreSQL they have provided the feature of BSON, like this binary JSON. So in a column, you can store the binary JSON in a way that you are storing the JSON inside the NoSQL. So it become a hybrid right now. This PostgreSQL become hybrid right now, and comes to this MongoDB. It is also providing you the functionality to store the structured data. So I just want you to go and check for this MongoDB that how it is storing the structured data like this SQL is doing. So you will get bit more idea. Okay, so it is the thing which is getting final right now. The line between these two is getting thin, and they both are adopting the features which they lack and which other is excellent. So currently these hybrid DBs are also there. So you need to cover those hybrid DBs as well. Okay, so everything is clear. Now let's come to the system design quiz. And I guess we have discussed a lot about this SQL and NoSQL. So first, let's see the question. You are building a banking application where user transfer money. Which DB? So if you are creating a banking application, there is a very simple answer. We are going to use the SQL. Okay. So what's the answer? SQL. Fine. You are building a backend for Roblox. Okay. Each NPC has completely different inventory item, stats, and nested dialog trees. Which DB? Again, the data is not structured. It can be anything that one user have something and other user have many things. So here we have a clear answer of NoSQL. Okay, so that is also correct. Scenario, you are starting a standard SaaS web app. You don't like writing schemas, which DB? So earlier we understood that if we are not uh, into the writing schemas, then this NoSQL is the correct answer. But if you are creating a standard SaaS web app, the standard answer is SQL, because do not pick NoSQL just because you are lazy. Default to SQL for a standard relational database to save yourself from massive data integrity headache later. So if you are just going to use the JSON, then it might create some data integrity issue. And that's it. That's it for this particular video. If you have any doubt, let me know into the comment section. I will help you. And if you like it, then share it, subscribe it. Thank you.